Hey everyone, this is a video created to help you with the last part of the Unit 11 packet that we were going to learn, which is regression. So you can follow along with either a copy of the notes or the pages in your packet, and then following reviewing this PowerPoint, you should be completing the week 1 assignment in ALEX.
Let's talk a little bit about correlation versus causation. Correlation is any relationship between two variables. And there are two main types of correlation. There's either positive, which means as one variable increases, the other one also increases. And then there's also negative, which means one of your variable increases, but the other decreases. And then there is no correlation, which means that there seems to be no relationship at all between two variables. So when you're thinking of positive correlation, think about like a linear function with a positive slope. It's not going to be a perfect line, but the points are closely modeling a line and they are going up from left to right. Whereas negative would have a negative slope. So again, your scatter plot, the points are closely related to a line and they are going down from left to right. And then for no correlation, your points would just be scattered everywhere and it would not look like a line at all. Now, causation is when something causes something to happen, and that is really hard to exist. Just because two things are correlated does not mean that there is causation. So you have to look at the scenarios and, individually to decide if causation does exist.
All right, so the first topic is correlation versus causation. So a lot of things in this world are correlated, meaning that they relate to one another. As one of them increases, maybe the other one is going to increase as well. But causation is when one action actually causes the other to happen. So if we look at like what's going on in our world right now, we've got people being diagnosed with coronavirus and we've got people staying home from work. Okay, so those two things are correlated because the more people who are diagnosed with coronavirus, the more people that are self-quarantining and staying home from work. But is the number of coronavirus cases causing people to stay home and self-quarantine? Yes, because those people that are getting sick or those people that are getting exposed to the sick person are then staying home. So that would also be an example of causation. So let's look at these 4 examples. The time you spent binge watching Netflix versus the amount of sleep that you get. So the more that you binge watch Netflix, what's going to happen to the sleep that you get? It's probably going to go down. So since the binge watching is going up and the amount of sleep is going down, those are going in different directions, making this negative correlation. Now the follow-up question is one causing the other? So is you binge watching Netflix causing you to get less sleep? Not necessarily. There could be other factors. You could end up getting the same amount of sleep. So this is going to be no causation. And excuse my handwriting. So part B, the amount of exercise versus the calories you burn. So again, if we think the more exercise I get, what's going to happen to the calories I burn? Well, I'm going to burn more calories. So that would be positive correlation since those are going in the same direction. Now again, follow-up question, is this correlation or is this also causation? So we definitely have positive correlation. Does the amount that you exercise cause you to actually burn more calories? Yes, so that would be causation. All right, the number of hours spent studying versus your assessment grade. So if we spend more hours studying, what do we think is going to happen to our assessment grade? It's probably going to also go up, making this positive correlation. But is this causation? Does studying more cause your assessment grade to go up? We know in math this is definitely not true. You need to practice, you need to do all sorts of things throughout the semester for your assessment grades to be high. So this is not going to be causation. You also have students who aren't going to study a lot and still make a high assessment grade. All right, your grade in algebra versus the number of followers that you have on Snapchat. This is obviously not related at all, so this would be no correlation. Correlation coefficient is the next thing that we're going to talk about, which represents the strength and the direction that a graph is going in. So if we think about a linear function, okay, a linear function creates this straight line that is either going in a positive direction or negative direction. Or in a sense of correlation, there could also be that there is really no direction, meaning that there's no correlation between the two variables. Again, excuse my handwriting. Okay, so positive correlation, and these are all scatter plots that we're going to create, because if we look at data, it's not going to be that it creates this perfect line. Okay, it's going to be as one goes up, the other one goes up, or as one goes up, the other one goes down. So positive would look something like this. Okay, if you made a line of best fit, it would have a positive slope. Whereas negative would mean that the data is going down, right? So this would be something along these lines where you could draw a line of best fit and it would have a negative slope. No correlation would be I can't figure out how to even make the line. So negative would be if my points are kind of all over the place and there's no relationship between the two variables whatsoever. Okay, so strength now is if I were to draw a line of best fit like on this positive graph right here, it would maybe look like this. Okay. The closer that those points fall to the line, the stronger the data. That means that there was really, it showed a lot of correlation between those, opposed to if I had points maybe out here and I add some more that are a little bit further from the line, then that's going to be weaker correlation. That data is not very close together. So we're going to represent strength with a variable called R. And R is also going to give us the direction. So R is actually called the correlation coefficient. And it's a number anywhere in between -1 and +1. Okay, so my correlation coefficient can't be like 2.5, right? It has to be some number in between -1 and +1. So right in the middle of those is 0. 0 means that there's absolutely no correlation whatsoever. So if you get a correlation coefficient of 0, then those two variables are not related to one another. Okay? 1 and -1 are the strongest possible data. So that would be that these points are almost perfectly all on the line that you have drawn. So the difference between 1 and -1 is obviously 1 is positive and 1 is negative. So that's affecting your direction. Okay, so 1 is very strong data and -1 is also very strong data. Just 1 would represent strong negative, and 1 would represent strong positive. Okay, so let's kind of make a line here. We'll put what's right in the middle of 0 and -1, -0.5, and over here +0.5. Okay, so anything sort of in this area right here, we would consider that to be moderate. The closer to 1, again, we can still call that strong. So maybe anything higher than about 0.8. Okay, anything between there moderate, anything in here is going to be very weak data. Okay, and the same goes if it's negative. So example 2, we're going to first order these scatter plots from the strongest to the weakest correlation, and then we're going to look at what the actual correlation coefficient could be. So depending on the strength and the direction of the scatter plot, that will help us to approximate a value for R. So if we're first looking at the strength of these, C would clearly be the strongest because those data points are all closest together. and then A would probably be the second strongest. Oops, that's not what I tried to do. Then we would have D, and then B would be the weakest correlation, okay? Now, if we look at A and C, those are both very strong data, but the biggest difference there is that one is going up and one is going down, meaning that if I'm going to talk about the strength and the direction of A, I can say that this is very strong data, but then because it's going down, that would make it negative. Okay, now to estimate a correlation coefficient, and we're going to make sure we don't use an equal sign because we are approximating. All right, you can look back at the chart that we made on the page before this. The closer to 1, the stronger the data is. Now this is negative, so we need to make sure we make it negative. And then it would probably be around 0.8 or 0.9 because this would be very strong data. All right, B, I'm not even really sure of the direction of this scatter plot, so this is going to be no correlation. So if it's no correlation, then R would be approximately 0. Okay, C was our strongest, so this is definitely strong data. And then the direction of it is positive. So since this is a little bit stronger than A, we can say that R is approximately 0.9. All right, and again, we're approximating, so there's definitely a wrong answer when you're approximating, but there's more than one right answer. All right, and then D, this is not quite strong, but it's not weak either, so in between would be moderate. So this is moderate, and then it is going down, so this would be negative. Okay, so R could be approximately 0.5, 0.6, and again, it's negative, so we'll say negative 0.6. So if you guys go to page 25 in your packet, you guys actually have a table there, and then you're creating a scatter plot based off of that table. So this is what the final scatter plot would look like after you put all those values onto the graph, which I trust that you guys can do on your own. So what we're going to do next is the regression equation, which is essentially just the line of best fit, which you guys have seen before. So in ALEKS, it's asking you to create a line of best fit for this graph. So in your packet, if you're following along with the notes, we are actually going to use a calculator to get the line of best fit, which if you have a calculator at home, you can utilize that. Or we gave you a website on the side of your packet as well that you can also go to, plug the numbers in from the table, and that will give you an approximate equation. Now, in ALEKS, it's not necessarily giving you a table, but it is giving you points, and it wants you to approximate where those points are and draw a line of best fit based on those points. So a line of best fit would be a line that maybe crosses through as many of the points as possible and goes through most of the data. So if I pick 2 points here, I'm going to pick the point in year 8, and I'm going to pick the point in year 2. And this isn't going to be perfect since I don't have a ruler, but if I connect those, it would look something like this. Okay, so now how do I create the equation for that line of best fit? Well, first I would need the slope. It's a linear function, so we're going to write it as y equals mx plus b. So to get the slope, we need the change in y over the change in x. So again, in ALEKS, you're going to have to approximate where these 2 points are. So if you're off a little bit, it's totally fine. We have the table here. So I know that in the 8th year, it was $21,100 minus in the 2nd year, it was $18,700. And then divided by 8 minus 2. Okay, and I can plug that into my calculator and I get 400. So that would be the slope for this line. Now to figure out what the y-intercept is going to be, I can utilize my slope-intercept form, and I can substitute in all the values that I know. So I know that the slope is 400, and then I have 2 points that went through my line. So you can pick either one of these points. If I pick this point right here, then the x value was 2, and the y value was 18,700. And now I solve this. So 400 times 2 would be 800. Move the 800 to the other side. And that would give me 17,900. So my final equation would be y equals 400x plus 17,900. And then if I wanted to find anything, which we're going to look at on the next slide, like what would it be, let's say 20 years from 2008, then I can plug 20 in for x. So now for page 26, to actually be able to utilize our equation, and you guys have done all this previously, but I'll walk you through these next 4 examples. So the equation above is the equation that you would have gotten using the calculator or using the website that we provided to you, where you can type the data in and it will generate an equation. That will also generate the correlation coefficient, which I did not talk about for this data. So it would give us R, and then we can use that to say whether this data was strong, moderate, weak, positive, or negative. So first, write a sentence to describe the meaning of the slope. So the slope for this equation is 449.91. So what does that mean? What does slope mean? Well, it means rise over run, but if I'm looking at the context of the problem, it's the change in y over the change in x, which for this scenario would be the change in cost over the change in years. So how much is the cost changing each year? And that's what the slope would represent. So the cost is going up by 449.91. And again, that's in thousands of dollars each year. So now write a sentence to interpret the value of your y-intercept. So the y-intercept from the equation is 17,369.82. Okay, so what does that mean for my graph? Well, the y-intercept is here, right? It's on my y-axis. So that's at 0. But this isn't actually year 0. This was years since 2008. So this number represents the cost in 2008. Okay, so does that value make any sense? Well, if we look back at our table, that's actually about 1,000 more than the actual amount in 2008. So it's a little bit off. If you have a TI-36X Pro or even a TI-36 or even a graphing calculator at home, any calculator that you can utilize Table for, you could use Table for both of these problems. We've used Table a lot this semester, and that comes in handy when we're doing these function notation problems. If you don't, totally fine. We should know how to find these still. If I'm trying to find C of 20, that means that my input is 20. So I'm going to plug 20 into this equation for X. 369.82. Okay, we plug it in and we get 26,368.02. Okay, so what does that mean? That means that would be the cost in 20 years. All right, use your equation to estimate when C of X will equal 30,000. So now I know that the output is 30,000. So if we're using our equation, I'm going to take my equation and set it equal to 30,000 and solve it. Okay, and this is just a two-step equation. So the first step would be to move this value to the other side. This cancels out. Okay, we've still got 449.91x, and that's going to be equal to 12,630.18, and then we can just divide. And we get that X is approximately 28. So what does that mean? X was the number of years since 2008. So that means 28 years after 2008, this would be the cost. Okay, that concludes this PowerPoint. So you guys should be going to Alex to complete the week 1 assignment, which has to do with regression. And feel free to text either Mrs. Mulligan, Mrs. Johnson, or Mrs. McAllister, whoever your teacher is, if you're having any trouble with any of the problems. Good luck.